Good afternoon, ladies and gentlemen. In this short video, I'm going to be preparing you for practice A of chapter 19. I draw your attention to a handout that I made for you that summarizes chapter 19, and we're talking magnetism. So we want to understand what's going on with magnets and what happens with the magnetic field and what direction does the magnetic field point to. From the outside, it's from north to south. From the inside, it's from south to north. And I also want you to pay attention to how the Earth, our planet Earth, has a magnetic field. In actuality, the north geometric or geographic pole is actually the south magnetic pole, which is why our magnets, the end part of our magnets, the north part, is pointing towards the south magnetic poles because south and north attract. Okay, so it's pointing towards the geographic North Pole, which is actually the South Magnetic Pole. And likewise, the South Geographic Pole is the North Magnetic Pole. Okay, and as many times as you split up those magnets, you're always going to have a South and a North. Doesn't matter how many times you break them up, you're going to have a North Pole and a South Pole. So I draw your attention to these equations. One of them is magnetic flux, and the other one has to do with magnetic force. How much force is there that pushes or wants to push something because of a magnetic field? B, capital B, is the variable we use to signify magnetic field. Okay, and B has the units of Tesla. So hopefully I get to talk to you guys about my work at General Electric with the MRI machines, which is a huge magnet, which has a huge amount of magnetic field. And V is velocity and Q is the charge. So we have charge, which is Q, which is in coulombs, velocity, which is meters per second, and Tesla. And you'll notice that if they're exactly 90 degrees from each other, the sign of 90 is 1. So then this goes away and it'd just be QVB for the magnetic force. And hopefully you'll see here, another picture I have in your textbook is one of the right-hand rules. So if you take your right hand, your thumb is pointing to a direction of the velocity, the fingers are pointing to the direction of the magnetic field, then the force is coming from the back of your hand out to the front of your hand. So that's how you figure out the direction if you're giving any of those three, because they're vectors, they have a direction. Okay, so it says unit Tesla. All right. The other thing I want to draw your attention to is to make sure you read this chapter. In your textbook, it's really short. And I also provided, I think, really good from the conceptual physics textbook. They've got just a more basic explanation of magnetism, which is going to help us before we get into induction and motors and generators to understand that. Okay, so here we go. Chapter 19. It's on page 696 in your text. And all we have are two problems, number 30 and number 31. So it says, number 30, a duck flying due east passes over Atlanta, Georgia, where the magnetic field of the Earth is 5.0 times 10 to the negative 5 Tesla. It's probably the same magnetic field here in Sacramento. So 0.000405 Tesla directed north. A duck has a positive charge of a certain amount of coulombs, also tiny 0.000704 coulombs. And if the magnetic force acting on the duck is, there's the force, 3 times 10 negative 11 newtons upward, what's the duck's velocity? Now, velocity, you remember, is a vector. So it has a magnitude, it has direction. So how do we set this up? Always, we just need to translate these given information. So we're given the magnetic field. How do I know that? Well, I know that the units of magnetic field is Tesla. And then we have charge. Oh, that's a clue for Q. Also Q, the units are coulombs. And then this one, you know, is force. Okay, so let's see. I wrote down the given information. Thought I had it ready. There we go. There we go. So there's the given information. The given information is the magnetic field is 5.0 times 10 to the negative 5 Tesla, pointing north. And then I have the charge Q is 4.0 times 10 to the negative C coulombs, and the force of the duck, 3.0 times 10 to the negative 11 newtons going up. What's the velocity? Now in your textbook, it says QVB, which kind of irritates me because it's actually QVB sine theta. And they do say in the textbook, we're going to assume everything is 90 degrees. Well, if that's the case, sine of 90 is equal to 1. So this part then is just 1. Okay, so it is equal to QVB. Fine. So we got the force, the magnetic force. We've got the Q, that gave us the Q right here. And we've got the B. So all we need to do is solve for the velocity. All right, so I want you to solve for the variable. So I want to know what V is. So if I divide both sides by Q and B, my Q's and B's cancel out on the right, and I'm left with V. So I have that the velocity is the magnetic force divided by QB. Simple enough. So again, this is going to be challenging. Make sure you know how to use your calculator, meaning using parentheses. Because I've told you many people set it up correctly, but then they don't get it right because they don't know how to use their calculator. So here I go. 3 times 10 to the negative newtons, that's up. And Q, we've got 4 times 10 to the negative 8 coulombs. And I'm going to multiply that, that's coulombs, multiply that by B, which is 5 times 10 to the negative 5 Tesla. All right, I can punch that in my calculator. Now what I like to do is I like to do the denominator first, and then I take the inverse of the denominator and multiply by the numerator. So let's see if I get that now. Here we go. 4, you can see my calculator, times 10 to the negative 8, bring down the cursor, times 5 times 10 to the negative 5. Nope. Shoot. Nope. I blew that whole thing. Try it again. 4 times 10 to the negative 8. Bring the cursor down. Times 5 times 10 to the, and I can't read my writing, negative 5. Right? Negative 5. Negative 5. Okay, bring that down. All right, so that's my denominator. Go ahead and give that to me. There's the denominator. Very nice. So I want to invert that, because if I invert that, then I can just multiply it to this guy. So give me the inverse of that. There's the inverse. Now I multiply that to the numerator. 3 times 10 to the negative 11. And I get 15, exactly 15 or 15.0 meters per second. Now the question is, how do you know that it's east? Because it is east, okay? So what we're going to do is we're going to look again here at this picture, the picture here. And I see that B has got to be my fingers, all right? And my force has got to be coming out. So I'm gonna orient my hand so it tells me what it is. All right, so north, I'm in Fair Oaks right now. So I'm going to show north is actually pointing this way. So my fingers are going to go towards the north. And then what else it told me? It told me that the force is up. Oops, I need to turn my hand up this way. So the force has got to be from the bottom of my hand to the top of my hand. The force is coming this way, and I've got my magnetic field going this way. So I look and see the direction of my thumb. And if north is this way, then obviously east is that way. And that's how come I know that the answer is east. Okay, so bottom line is you need to just have the equation of F magnetic is QVB. It's really QVB sine theta. But they tell us in this book, everything's going to be 90 degrees to maximize the magnetic field or the force. All right, so we end up with 15 meters per second exactly. So let's take a look at the next problem. Let's see, and I had set it up here also. Let's see, here we go. B, problem B. Oops, I wanted to. There we go, just problem B for now. A proton moves eastward in the plane of Earth's magnetic equator, where Earth's magnetic field points to the north, has a magnitude of 5 times 10 negative 5 Tesla, same as before in the previous problem. What velocity must the proton have for the magnetic force to just cancel the gravitational force? All right, so what does it tell me? It tells me the magnetic field, so that would be capital B. And then it's telling me that it wants to know what the velocity is. So it's assuming I know things. Well, I know from a proton in my textbook, I can look up what the mass is and what the charge is. Remember, the charge is the same as an electron, except it's positive instead of negative for electron. All right, so I set this up. Here we go. I just drew it up here. I've got a little proton, which I just put a plus sign inside a circle, and it's moving to the east. And I have the magnetic field V as 5.0 times 10 to the negative 5 Tesla. I want to know what the velocity is. And the force of the proton, cancels the gravitational force. Hopefully you remember that F sub G, gravitational force, is the same thing as the mass times acceleration due to gravity. So I went and looked it up in the book, and I found that the mass of the proton, I think I found this online, I think the book has 1.67. So I went with the book, the online, 1.672 times 10 to the negative 27 kilograms. That's the mass. And the charge is 1.6 times 10 to the negative 19 C. And you've used this charge in previous homework assignments. All right, so I need to have the force cancel out the force. Well, we need to figure out what this force is. We need to figure out what mg is. Here's my m, and the g, you guys probably all know, is 9.81 meters per second squared. So I've got 1.672 times 10 to the negative 27 kilograms. All that times 9.81 meters per second squared, and that'll give me newtons. See what that is? Okay, let's clear this. I've got 1.672 times 10 to the, and it's negative 27 times 9.81. All right, I get this tiny number here. Confirm. 1.64, I'll probably just use it from my calculator. I like to do that. 02 times 10 to the negative 26 newtons. Okay, so now I have my force. That's what my force is going to be. They wanted to cancel that out, so there's how much force it is. So this problem is very similar to the other one because now I've got the force. I've got the B. We're looking for velocity. Oh, what's Q? Well, Q is what we had to look up. The charge for all electrons, protons negative, protons positive, 1.6 times 10 to the negative 19 coulombs. So again, we're going to solve for V by dividing QB to both sides. So V is just the magnetic force divided by QB. And my force, I just figured out, is this big old long number, 1.6402 times 10 to the negative 26. But of course, I will use the number on the calculator. All right, divided by, let's see, Q is the 1.6 times 10 to the negative 19 coulombs. And B, that's what they gave you earlier here, is 5 times 10 to the negative 5 Tesla. All right, let's see, I've got this here already. So I'm going to say divide this by, since it's there already, and I'm going to put these in parentheses to make sure that it divides these guys multiplied. Here we go, 1.6 times 10 to the, I read my writing, negative 19. That's the Q, times the other one, 5 times 10 to the negative 5. Uh-oh. All right, here we go. To the, let me clear that number. Rats. All right, we're going to do that again. Let's say take all that divided by, I've got to pay attention and bring down my cursor. 1.6 times 10 to the negative 19. Bring the cursor down. There we go. Times 5 times 10 to the negative 5. There we go. And I'm going to close the parentheses. First, bring the cursor down. Close the parentheses. Okay. All right. Where did I make my mistake? Hopefully you guys can see where I made my mistake. Looks like I put the times there inside. All right. Well, I'm going to clear this. Here we go. 1.6 times, let's see, to the, does it know that? Yes, here we go. Negative 19. Bring this down, times 5 times 10 to the, go down by, nope. Keep hitting the wrong thing, I apologize. Well, ladies and gentlemen, I did do this correctly before. So I'll just show you what I got before. When you do this, you get this really small number, 0.002051515 meters per second. And so here's a good place for you to express it with scientific notation. So now it's really up to you to decide when it makes sense, okay, to be professional here. Here we worry about how many significant figures and so on. So it might be 2 because they only gave you 1 here. I always give it 1 extra. 2.1 times 10 to the negative 3 meters per second. Okay, so that's all we have to do for this problem. And again, it goes back to the magnetic force is QVB. And this, of course, assuming that theta is 90. They're orthogonal, which is another word for perpendicular, because it's sine of theta, and the sine of 90 is 1. Okay, so the next one I'll do for practice B. So that's all I have for you guys.